must be different. For example, distance and time in case of the car, mass and cost in case of the gold. When we say a car travels at 180 kilometers per hour, it means after every 1 hour the car covers 180 kilometers. Thus, after 10 hours the car will be 1,800 kilometers away from the starting point. The rate of change distance with time is called speed or velocity if the travel is in a straight line. The rate of change of speed with time is called acceleration. The rate of change of mass with volume is called density. The units of rate depend on those of the two quantities in question, that is, kilometers per hour, meters per second squared, kilograms per meter cubed, and so forth. For example, a motorist traveling at 120 kilometers per hour completes a journey in 2 hours. Suppose he had traveled at 80 kilometers per hour. How long would he have taken? The rate we are using is speed. Speed is equal to distance over time. If the speed is 120 kilometers in 1 hour, then in 2 hours the motorist covered a distance of 120 times 2, which is 240 kilometers. Certainly, this was the distance of the entire journey. Suppose he had been slower, traveling at 80 kilometers per hour. If he was covering 80 kilometers in 1 hour, he would take 240 over 80 hours to cover a distance of 240 kilometers, and that gives us 3 hours. Ratios. When we say the ratio of boys to girls in a class is 3:2, it means that for every 3 boys you encounter, there are 3 girls. This can be represented as B to G is equal to 3:2. If you reverse one side of the expression, you must reverse the other. That is, G to B is equal to 2 to 3. Ratios are used to compare 2 or more quantities of the same kind, e.g., students. Ratios can also be expressed as fractions. That is, G over B is equal to 2 over 3, or B over G is equal to 3 over 2. It is important to note that ratios must not always be whole numbers. They can be fractions. For example, A to B is equal to a third to a fifth. However, it is always safer and easier to work with whole numbers. To convert fraction ratios into whole numbers, we multiply them with the LCM of their denominators. That is, a third times 15 and a fifth times 15, so that the ratio becomes 5:3. The ratio A to B is equal to a third to a fifth, which is equal to 5:3. Equality of ratios. Just like 2/4 is equal to 1/2, the ratio 5:10 is equal to 1:2. Thus, a ratio is unaltered if the two numbers are multiplied or divided by the same number. Proportions. We have seen what equivalent ratios are. The ratio 3:5 is equal to the ratio 12:20. This can be written as 3/5 is equal to 12/20, read as 3:5 as 12:20. When two ratios are written like that, it is called a proportion. In a proportion, the numbers next to the equal sign are called means, and those further are called extremes. That is, for the ratios 3:5 as 12:20, 3 and 20 are extremes, 5 and 12 are means. In a true proportion, the product of the means equal to that of the extremes. That is, 3 times 20 is equal to 5 times 12. For example, solve 5/4 is equal to 15/x. Applying the same principle, we can have 5 to 4 is equal to 15 to x. 4 times 15 is equal to 5 times x. Solving that, we find x is equal to 12. Let's take a look at a real-life example. The ratio of boys to girls in a class is 3:2. If there are 120 students, how many boys are in that class? And if 12 boys left and 12 girls joined, what is the new ratio? In our solution, for every 5 students, 3 are boys and 2 are girls. So, in a class of 120 students, we will have 3/5 times 120 boys, which will give us 72. This means that there are 120 minus 72 girls, which gives us 48. You can still calculate it as 2/5 times 120. Now, if 20 boys left, we will have 72 minus 12, which is equal to 50. If 30 girls joined, we will have 48 plus 12, which is 60. The new boys to girls ratio will be 50 to 60, which simply means 5 to 6. Change in ratios. In our example, the girls' population changed from 48 to 60. The ratio of old to new population is 48 to 60, which is 4 to 5. We say that the population of girls has been increased in the ratio 4 to 5. This means that new population is equal to 5/4 times old population. For the boys, the population decreased from 72 to 50. It decreased in the ratio 72 to 50, which is equal to 36 to 25. That means new population is equal to 25 over 36 times old population. The fraction that must be multiplied by old population to give the new population is called the multiplying factor. In our case, 5 over 4 and 25 over 36 are the multiplying factors. Please note the arrangement of the ratio to form fractions in the respective scenarios, that is, increase and decrease. Direct and inverse proportions. Consider a car speeding on a highway. The speed of the car is constant. The distance covered increases with time. In such cases, we say that distance and time are directly proportional. Two quantities are said to be directly proportional if they increase or decrease at the same rate. If a man walks at a speed of 2 kilometers per hour, the distance he covers increases with time. We thus say that distance is directly proportional to time. When x and y are directly proportional,